This is chapter 17 titled Binary Input and Output. In this chapter we're going to discuss, it's going to be very similar to what we learned, I think it was back in chapter 12 where we discussed file input and output, but the slight difference will be instead of dealing with textual data, we will now be dealing with binary data. For this lecture, I'm going to provide a quick introduction of what binary is when it comes to just data itself. I will then talk about something we've discussed previously. I think it was back in chapter 12 or 13, if I'm not mistaken. This is where we discussed how to write text to data and store that, or read textual data from a file. So we're going to do a quick review on that. That way we can be better oriented to understand this whole concept of binary input and output. Then we're going to actually talk about binary input and output, and I'm going to talk about the what it looks like, what's entailed with it. Compared to text input and output, there are some noticeable differences, and it's really important that you understand the differences between text I/O and binary I/O. And then we're going to discuss how to read and write binary data. I do also have some lab examples. I'm not going to go over the lab examples in this lecture. I may not even have a video for the lab examples. You may just see them posted. But those lab examples are the first 3 programming assignments in Chapter 17. So that's 17.1. 17.2 and 17.3, and I'll mention this again towards the end of the lecture. And please, when you get a chance, look it over. Make sure you understand it. You may be assigned these problems, or you may see this sometime later down the road. So, introduction. Data. We know that data, at least to this point, we've been saving data to text. And when we save data to text, what that means is if I have textual data and I use a text editor like Microsoft Word or Notepad, then I can actually manipulate that data, see that data, save the data. Same thing in JGrasp. I can also save .java files in JGrasp, and that's human readable text data. But there's another kind of data, and that's binary data that is also stored on the computer. And binary files are only read by the computer. For example, when we compile our .java files, they get compiled into a .class file. It's the .class file that gets run when we execute a Java program. Now, if you've been in my class, either in 2301 or 2302, we've actually used JGrasp to open up a .class file. If you have not done that, go ahead and do that at this time and just see what will happen. You can legally open it. It's not going to crash your computer. You'll just be presented with unreadable data, and that is I call that's the matrix, and that's the binary data that you see that the computer understands, but we cannot comprehend. Interestingly enough, everything on the computer is actually stored in binary. So when I have a Microsoft Word file, or when I have a Notepad file, while let's say I'm creating a text file, when I hit save, it's not saving textual data. It's actually converting that data to binary and saving that data as binary. When I open it in a textual text editor, like Microsoft Word or Notepad, it does the conversion again. It converts it back to human readable text. So let's make sure we understand this. The computer needs binary. The computer only understands binary. Things are going to be saved on the computer in binary format. The things that we are able to manipulate and read and view and save and things of that nature, there is a layer there. There's a conversion layer that's converting it to binary when we want to save it, and it's converting it from binary when we want to view it. So of course, that extra step takes time. And that is why binary, just a straight binary input and output, is much more efficient. There's no conversion needed in those cases. That's why it's really important to understand what's going on in this chapter. This is why the author provided this chapter in this book, is to understand, how to use binary. In almost all software that is commercially available, there's some type of binary principles being done. There's some type of data is being saved as binary files, or the software requires reading binary data, things of that nature. So it's really important that you guys have at least be introduced to this, and then later on, probably later in your matriculation in the CS program, you'll be asked to do more programming activities that involve binary storage and retrieval. So let's quickly review just textual data, text input and output. As you guys can recall, there's a file class. A file class is useful for creating an object that encapsulates the properties of a file or folder. Again, a file class cannot be used to read or write directly to a file. It only points to that file or folder. We need other classes that allow us to either read data to the file or write data to the file. I'm sorry, read data from the file or write data to the file. If we want to write data to the file, then we can use a print writer class. And here's an example of a print writer class. I create a print writer object, and in the new print writer, I can either pass the name of the file, or I can actually pass a file object. And then I can use the output.print, because the print method is part of the print writer class. And it's also important if you're dealing with print writers, that once you're done, and this is just a reminder to use that output.close, otherwise your data won't be saved to the file. Now, if I want to read data from a file, we can use a scanner class. And you can see here, scanner input equals new scanner. There's my instantiation of a file object that points to temp.txt. And then I can use methods inside the scanner class that allow me to read the file. For example, input.nextLine. So this is how we deal and handle with textual data, and we want to either write to files or read from files. Now, when it comes to binary data, it's going to be similar, but there are some differences. And here's, if I wanted to write binary data, I'm going to use a class called a data output stream. And the best way to write, when we're dealing with binary, the best way to do it, if I want to do a write, this is the best way to go about it, at least the most efficient way to go about it, is creating an object of data output stream, and then inside the as arguments, I'm going to pass a buffered output stream, and then inside the buffered output stream, I'm going to give it a pointer to a file object. Okay, so you can see there's an extra layer here. Instead of having my output stream connected directly to my file stream, I actually have this buffered output stream. I want to talk about why after I introduce and go over the read, but I just want you to understand right now, once I've done this, then the write methods are part of the data output stream. In this case, they will be part of the output object. Okay, so it'll be output.write int, and I can pass it an int. Now I can write chars or bytes. I can write. There's a lot of different methods I can use to write. And if you're dealing with a data output stream, I encourage you to look at the Java docs to find the specific or the best writing method you want to go with for that particular data that you're trying to write to the file. Now let's look at read. So with the read, I'm going to use the data input stream, and again I have that point inside as an argument, buffered input stream, and then inside the buffered input stream I have my file pointer object. When I am doing a read, similar to a scanner, I have that scanner.hasNext, or the scanner object.hasNext. For a read for a data input stream, I would use the input.available open close parentheses greater than 0 as my terminal statement in my while loop. And that statement will allow me to read through a file until I reach the end of file. And then I could use a read method to grab data, and I need to know what kind of data I want to grab. If I want to grab an int, then I want to use the read in command that returns an int. Things of that nature. So now let me go back to, let's now talk a little more detail with the buffered input stream and the buffered output stream. What buffered, now again, binary data is more efficient than textual data. So, and what a buffered output stream and what a buffered input stream does, it reads that file, it reads the file, or I'm sorry, it saves all the data to a buffer, and then if I'm going to write data to the file, then it writes at the very end. If I'm reading data from a file, it reads all that data first to a buffer, and then if I do those read in commands or things of that nature, it's reading it from the buffer. It's not reading it from the file. And the reason for that is if I have to continue to go through a file, there's actually a time lag. There is a performance hit when I am actually operating with a file. What I prefer to do is store all my contents in a buffer and then parse through that buffer, and that is a much more efficient way of going about it. Now, 10 years ago, when I was your age programming, this was starting to gain some momentum, and especially 15 years ago and 20 years ago, actually, when I really got into programming, hardly anyone did buffered input streams or buffered output streams. No one ever wrote stuff to a buffer. The reason for that, memory back then was at a premium. It was hard to find computers with sufficient memory to run a lot of stuff. So it was really bad programming practice to write everything to a buffer. It was better to just take that performance hit and just go through a file. In today's world, computers have an expansive amount of memory. We're no longer concerned with that. What we are concerned with is making sure our programs operate efficiently. So this is why now that memory is no longer an issue, we can store all our stuff on a buffer, operate on that buffer, and we'll be good to go. So again, that's why we have that extra layer here. You can also have that extra layer there when we do textual data as well. The reason why I think it's much more of a necessity to do it with binary data is because binary in its core principle is already designed to be more efficient. So we might as well continue to utilize the other efficient mechanisms to make sure we have a streamlined process. Okay. All right. So let's compare text in I/O versus binary output I/O. With text I/O, it requires encoding and decoding, as I already said from the beginning. When I have a text file, it has to first convert it. That converting is encoding, so I'm taking textual data and I'm encoding it to binary data. If I want to read data from a file, then I have to decode, which means I have data that's stored as binary and needs to be decoded back to text. And then our text editor is already designed to automatically do this conversion. You guys probably didn't even know that was going on, but that's what happens with text input and output. So here's an example. The number 199 in text is translated to that long string of ones and zeros. If you're not familiar with binary, I would love to spend some time discussing binary. As a computer science major, I think it's important, very essential to understand binary and even hexadecimal format. But for the purposes of this class, I'm going to have to, unfortunately, just skip over it. Hopefully in a later time you guys will be introduced or have a class where you can actually talk more about binary data. But for this particular case, let me just go with it. So 199 in text, we translate to that long string. What happens is it has to take each item and separate it and then make the conversion. So the first item is the 1. It converts to 1, which is 31 in ASCII, and it converts that 31 into that binary representation that you see on the screen. It does the same thing for the second 9, and then it does the same thing for that final 9. Now, if I was just doing binary data, it would just take a straight translation of the number 199 and convert it to what 199 is in binary. So you can see why binary is much more efficient. We don't have to worry about breaking things up and storing it separately. Excuse me for that, guys. Finally, I just want to reiterate that I have programming activities already completed. Again, these are for 17.1, 17.2, 17.3, where you're being asked to, well, in the first case, you're being asked to just deal with text data, but in 17.2 and 17.3, you work with reading or writing data to a binary file, and then in 17.3, you're going to read that data from a file. I strongly suggest that you look it over, become more familiar with methods and the structure on how to use binary input and output. And that will conclude our lecture.